So you should have calculated your average K by now. Okay? And then I just handed out a new sheet to you. So, Matt, what was your average K?
I didn't get one yet.
Okay. Felipe? No? All right.
I haven't got mine.
You got yours, Ava?
No, not yet. Well, ours have to be very accurate.
John?
No, I'm close.
Anyone?
I'm one value over.
Anyone at all? Anyone have their average K? Well, anyhow, once you do have your average K, then you're going to use experiment 8 as a check on your data. In other words, you're going to calculate what the rate should have been, because you know your K, because you calculated your average K right there. And we know the values for experiment 8.
You want the average now? I got one.
Yeah, why don't you just give me an average K?
Shop junk here. 6.129 times 10 to the negative fifth.
So you use your average K, 6.12, and then take the concentration from experiment 8, raise it to the power that you found. Now, the lab group that I work had it to that power. Your next concentration, raise it to the power that you found. And you're going to calculate the rate. Calculate what the rate should have been. And then compare that to the rate you actually measured. So my lab group measured the rate to be 3.5 times 10 to the negative 7. So calculate your rate, compare it to the measured rate by doing the percent error. I will let you do that later because I want us to kind of move on to phase 2, which is to calculate the activation energy. All right, what was the temperature of the hottest water bath?
74 degrees.
Actually, I'm going to use a different, I'm going to use, guys, 74 degrees,
74.4 degrees Celsius.
okay? Then what was the other water bath, 37 about?
About 35.5.
Okay. And then we had
Zero.
room temp.
Oh, yeah. Well, yeah.
Room temp was 22. And then the cold water bath was
0.
Was it 0? Okay. So you're reproducing this for experiment 1. So you redid experiment 1 at those 4 temperatures. And we have to convert it to Kelvin. And obviously use your temperatures. Okay, use your temperatures. I'm going to convert them to Kelvin right now myself. Then once I have my temperature in Kelvin, I'm going to take 1 over the temperature. And I'm going to keep my 4 siggy figgies. Then I'm gonna write down the rate. Now, we know the rate for this one already because that was the room temperature run from experiment number 1. So I know that rate right off the bat because it's right here on data table 1. Okay, you will have to go back and recalculate the rate. You remember how to do it? Take the concentration of the thiocyanate, thiosulfate, which was 8.3 times 10 to the negative fifth, divided by 6, divided by your time to find those other rates. Now, if everything goes well, what should happen to the rate as temperature goes up?
Increase.
Should increase. Cross your fingers, but it should go up. And then it might actually have been nice to have one other column in here. Find K. What was the value of K for experiment 1? I'm just going to pick on you, Ava. What was your K value for experiment 1? Not your average, just your for experiment 1.
4.28 times 10 to the negative fifth.
4 point what?
Or 4.28 times 10 to the negative fifth.
Okay. So you found K. We know the whole rate law now. Find K with the new temperatures. So you've got a new rate. Okay, you've got a new rate. Find K, and then take the ln of that. You really got 4.2 times 10 to the negative fifth for experiment 1, the K value?
You betcha.
Okay.
This is like a big number.
Usually they're big, well, I shouldn't say usually. For
We
this,
got some 9s in there too. Like some of our other ones.
usually for this experiment, this reaction, it's above 1.
Okay, so we're not as up as I thought.
And sometimes they're up into the 10s and the 100s.
Oh, okay.
Good.
So we're good.
This looks good, actually, this average. That average looks good,
Well, we had some 9s up there. Too.
so. But anyhow, you take the ln on that.
Oh, ours was like 1, so.
Just redo those later.
No, mine was a little one. Yours is gonna probably come out better.
So if I got one half of the
And then once you complete those 2 columns, you're going to graph this versus this. So once you have that data table out, you're going to graph this versus this. 1 over t is on the x, and ln of k is on the y. And I think until we have a graph, we're going to hold off. But spoiler alert, sorry for those of you at home, you might want to close your ears right now. The slope is going to be equal to negative EA over R, where EA is the activation energy. So once you find your slope, divide it by, or multiply it by R, and in this case, R is 8.31 joules mole Kelvin, you'll be able to find the activation energy for this reaction. Thereby fulfilling your life and your dreams and your aspirations. So if you have any questions, feel free to email me, text me. And to our friends in Germany, Dobranoc. No, that's Polish. Sorry. Guten Sieben.
Good
What?
7.
Good evening. Guten Abend. That's right.
7.
Guten Abend.
You can also say auf Wiedersehen.
Auf Wiedersehen.
Auf Wiedersehen.
Auf Wiedersehen. All right.
Tschüss.
Adios.
Okay.
Bis später. Yikes.